Okay, we're going over the 7A review. Number 1, the angle of depression from an airplane to the airport is 34 degrees. So we have the airplane somewhere up here. Just kind of drawing some sort of airplane. This is angle of depression from the airport. So as it's flying, angle of depression is always from a horizontal line. So this is your 34 degrees. The pilot reports that the plane's altitude, so that's this height right here, is 3,200 feet. We want to find the horizontal distance between the plane and the airport to the nearest foot. So this is what I'm solving for, the horizontal distance. So let's go ahead and label what the side lengths are that we have in the picture. If this is my reference angle, this over here is considered the opposite side. This is the adjacent side, and the trig function that uses opposite and adjacent is tangent. Tangent of 34 degrees is equal to opposite, which is the 3,200, over the adjacent, which is x. We're going to cross multiply to solve for the side length. So if I cross multiply, we get 34, or tangent 34 degrees times x equals 1 times 3,200. To get x by itself, we'll divide by tangent of 34 degrees. And then we're going to plug this into our calculator. Keep in mind that you have to make sure that you are in degree mode in the calculator. So we are going to do 3,200 divided by tangent of 34 degrees. And this gets you approximately 4,740 nearest foot, so whole number, 4 feet. Okay, this next one that we have says that you want to find the height of the tower used to transmit cellular phone calls, and you stand 100 feet away from the tower and measures the angle of elevation to be 40 degrees. How high is the tower to the nearest foot? Let's go ahead and put a tower over here, and you are measuring yourself to be 100 feet away from this tower, so there's 100 feet. And the angle of elevation, remember, angle of elevation and depression always are from the horizontal. So this is our 40 degrees. How high is the tower to the nearest foot? So this is our x. So trying to figure out the trig function, this is considered opposite, this is considered adjacent. So we're looking at tangent. So tangent of 40 degrees equals opposite x over adjacent 100. And we're going to cross multiply. So to cross multiply, we get 1 times x is x, and tangent 40 degrees times 100. So when you plug it in, again, make sure you're in degree mode. So we're going to plug that in. And we have, let's see if we get this, 100 tangent of 40 degrees. And this is going to be rounding again to the nearest foot, which is going to be approximately 8 feet. I just realized that I actually put in 10 tangent instead of 100. 100 tangent of 40, which will move the decimal over 1. So this should have been actually 84 feet. So that should be 84 feet. Okay, this next one says that a 50-foot ramp makes a 4.9 degrees with a horizontal ground. To meet new accessibility guidelines to a new ramp must be built so it made an angle of 2.7 degrees with a horizontal ground. What will be the length of this new ramp? So we know that the 50-foot ramp, so a ramp is diagonal. Let's go ahead and draw the first one here. So the ramp itself, this is the ramp going up. So that should be the 50 feet here. And it makes 4.9 degrees with the horizontal ground. So this is 4.9 degrees right here. And in order to make the new ramp, so we're going to have a new ramp here, keeping in mind that this height needs to be the same because it needs to enter whatever the doorway is to that. So this should be the same value. But it's going to have to be a different angle measure here. So this is the 2.7 degrees. And we're going to have to figure out what is this new ramp height here. All right, so or new ramp length. So what we're going to have to do is two different triangles. This first triangle that I'm going to use, I'm going to actually solve for what this length is so I can figure out from here. Now keep in mind, I'm going to make this, let's say, the H for the height going inside the doorway, because a ramp is built to go inside some sort of doorway usually. All right, so we have opposite and we have hypotenuse. O and H is sine. So opposite is H over hypotenuse, which is 50. Cross multiply, we get H equals 50, sine of 4.9 degrees. So we're going to use our graphing calculator and put in 50 sine of 4.9. Make sure you're in degree mode. And then that gets you a height of about 4.27. All right, so using that height for this side right here, 4.27, we want to find out what is this new length. So again, this is going to be opposite and hypotenuse. So we're going to use sine of 2.7 degrees equals opposite 4.27 over hypotenuse, which I'm solving for. All right, we're going to cross multiply. So we have sine of 2.7 degrees times x equals 1 times 4.27. You're going to have to divide by sine of 2.7. And then we're going to plug into the calculator the 4.27 divided by sine of 2.7. And that's going to get us approximately 90.6, and this is in feet. Okay, in this one we're trying to find the nearest degree for what angle this brace, so here's the brace here, makes with the wall, so right here. So with brace, with the wall, we're looking for the measurement of angle C. So let's go ahead and find the measurement of angle C. Now to find angle C, I do know these two sides. Since angle C is my reference angle, this would be opposite, and this would be the hypotenuse. Opposite and hypotenuse, that's going to use sine. So sine of angle C equals opposite, 26, over hypotenuse, 32. And to get rid of sine, you have to use the inverse, which is sine with the minus 1. And we're trying to find this to the nearest degree. So again, we still want to be in degree mode. So what we're going to do is we're going to plug this into our calculator here. And we get inverse sine by second, and then hitting the sine button. 26 divided by 32. And this gets us a value of approximately 54 degrees. And then for part B, it's asking us to the nearest degree, what angle does the brace make with a shelf? So here's the brace, here's the shelf. So our reference angle now is A. So the two sides that I have here is the adjacent and the hypotenuse. If angle A is our new reference angle for part B here, we have adjacent, hypotenuse. So adjacent hypotenuse is cosine. Cosine of angle A is adjacent, 26, over hypotenuse, 32. And then we're going to get rid of cosine by doing the cosine inverse. So we're going to plug into our calculators the inverse cosine of 26 over 32. All right, so make sure you're still in degree mode. So we go second cosine, and 26 divided by 32 gets us about 36, well actually, like 36 degrees. Oh, we could have done this much easier, right? So I just did this both using trig, but technically once you have one angle measure and you know that's 90, then you could subtract from these two from 180 and get the 36. That would have been another way. Okay. Okay, so for number 5, part A and part B actually, this doesn't tell you which of the laws to use. You're using law of sines or law of cosines. Law of cosines, if you want to memorize it as being side, 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 or side angle side, that's when you use law of cosines. Otherwise, everything else is law of sines. So if you look at this picture here, I happen to have side, side, side. So I'm going to use the law of cosines. So law of cosines, you have to pick which angle you want to start with. So let's say I want to solve for angle A first. So if I solve for angle A, I have to start with side A, which is opposite. So 41 squared equals, and then the other two sides, and we have 15 squared plus 52 squared minus 2 times those values, 15 and 52, cosine of angle A. Now we have to get A by itself, so we have to get rid of adding, subtracting first. So 41 squared minus 15 squared minus 52 squared equals negative 2 times 15 times 52 cosine of A. To get rid of this, we have to actually divide that to the other side. Negative 2 times 15, 52. And that cancels all of this. And so we're going to have to put this into the calculator. But I'm going to put it all in one shot. So before I put it in, though, I want to go ahead and do the inverse cosine so I can get cosine to go away. So inverse cosine is cosine with the little minus 1. And put all that in the calculator one shot. So to put that in, I'm going to go second cosine, and you could put it in as a fraction if you want to. I'm going to put it in so it's a little more clearly written there when I'm putting in 41 squared minus 15 squared minus 52 squared, all divided by negative 2 times 15 times 52. And that's going to get me approximately 36.9 degrees. So that's going to be angle A, 36.9 degrees. All right, and then you could pick another one of these angles to solve for. So I'm going to go ahead and solve for, I don't know, angle B. So if I solve for angle B, I start with side B, which is across from it. That's 15 squared equals the other two sides, it doesn't matter what order, 41 squared plus 52 squared minus 2 times 41 times 52, and then cosine of angle B. All right, again, I'm going to have to move these over by subtracting 15 squared minus 41 squared minus 52 squared, and I'm going to divide this to the other side. Negative 2 times 41 times 52. To get rid of cosine, we're going to do the cosine inverse. And so we're plugging that into the calculator now. So I'm going to go and plug that in. So second cosine, and I'm going to put it in as a fraction. And I have 15 squared minus 41 squared minus 52 squared, and then divided by negative 2 times 41 times 52. All right, and that gets us approximately 12.68 or 12 oh, we were rounding to the nearest tenth on the answer key, so I'll go 12.7. So that's the measurement of angle B. Okay, and you don't have to do this a third time because I have these two angles. If you just add these up and subtract it from 180, that'll get you C. 180 minus the 36.9 and the 12.7. And this is going to get us angle C, which is approximately 130.4 degrees. Okay, part B is a little different. We have angle, side angle. So remember, law of cosines is only side, 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 and side angle, side. So we're going to have to use the law of sines for this. All right, so we need to know one of the angles and the side across from it. This is the only value I know, so I actually have to have that angle measured before I even start. So actually, to find that angle measure, if I have the other two angles, I can find the measurement of angle B by just taking 180 and subtracting the 45 and the 55 from that. And that's going to get us 80. So angle B is 80 degrees. And now we can go ahead and set up our law of sines. So since I know this is 80 degrees, I'm going to use sine of 80 degrees over the side opposite of that, which is 10, equals, and then pick which one you want to solve for first. I'm going to solve for side A, which means I have to use 45. Sine of 45 degrees over A. And then we're going to cross multiply. So multiplying across this way and then this way. So we have sine 80 degrees times A. And keep in mind, remember that's together. And then we have 10 sine of 45 degrees. And then to get rid of the sine 80, I'm going to divide. And then we're plugging this into the calculator. Remember, sines don't cancel. It's just plugging it into the calculator. So we have 10 sine of 45 degrees divided by sine of 80. And that's going to get us approximately, we do approximation, 7.2 for side A. And then the last side that I want to solve for is side C. So to solve for side C, I'm going to go ahead and set it up again. I have sine of 80 degrees over 10 using the same ratio as the beginning. But this time I want C, so I'm going to use sine of 55 degrees divided by side C. Again, I'm going to cross multiply. So we get C sine of 80 degrees equals 10 sine of 55 degrees. To get rid of sine 80, sine 80, I'm going to cancel by dividing it on both sides. All right, so now I'm going to go ahead and put this into the calculator. So I have 10 sine of 55 divided by sine of 80. And that gets us a value of about 8.3. And that solves the triangle. Okay, part C does not give me a picture, but you could draw a picture. All you need to know are what the letters we have here. So this is all based off triangle ABC. I have B and C, but I don't have A. You could put it in any order you want, as long as you put these values next to the appropriate sides. So B is 85 degrees, angle C is 38 degrees, and side C, which is across from angle C, is 6. So you have to find these two sides and the angle measure here. We have angle, angle, side. That's going to be law of sines. Remember, law of cosines is only side, 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 and side, angle, side. So we're going to go ahead and use our law of sines. Before I do that, I'm going to go ahead and solve for this missing angle here. So to find the measurement of angle A, I'm just going to take 180 and subtract 85 and 38 from that. And that's going to get me, let's see, 180 minus 85 and 38 is 57 degrees. All right, so I have that angle, and now I'm going to go ahead and figure out which side I want to solve for. So let's say I want to solve for side B. That means I'm going to use the pair that I know. So that sine of angle 38 degrees goes with side 6, that's the pair, equals sine of 85 degrees over, and I want to know what side B is. We're going to cross multiply. So B times this sine of 38 degrees equals 6 sine of 85 degrees. I'm going to take that and divide both sides by sine of 38 degrees. And then plug that into the calculator. So plugging it into the calculator, I have 6 sine of 85 and the parenthesis before you divide by sine of 38. And that means B is going to be approximately 9.7. All right, and now we have to solve for one more side, and that's side A. I found angle A is 57, so I'm going to use the same ratio. I'm going to use sine of 38 degrees over 6 equals, and since I'm solving for angle A, side A, I have to use angle A. Sine of 57 degrees over side A. Cross multiply, multiplying across this way, we have A sine of 38 degrees equals it this way, 6 sine of 57 degrees. To get rid of the sine of 38 degrees, I'm going to divide 38 sine of 38, and then we're plugging that into the calculator. So we have 6 sine of 57 divided by sine of 38, and that gets us a value that's approximately 8.2. Okay, we're moving on to number 6. On number 6, you have to find the area here of this triangular garden. And using our formula for, with using trig, we have 1/2 times the two side lengths, which are 8 and 13, multiplied by sine of the angle between. It's a formula you had to know. 1/2 times the two side lengths and the angle in between. Make sure you use sine. And we're just going to plug that into the calculator. So I have 0.5, or you can put 1/2 in there. And then we have times 8 times 13 sine of 70. And that gets us approximately 48.9. So that's 48.9 feet squared. Okay, and then number 7, what we're going to do is find the reference angle for each measure. Keep in mind reference angles are always positive. So I'm going to draw in where negative 150 degrees is. Remember, you're going backwards because it's negative. Excuse me. Negative 150 degrees is between negative 90 and negative 180. So it's over here. Keeping in mind the reference angle is always closest to the origin here. I know this one is 150 degrees. So in order to make it to 180, I just need a little bit more. How much more? We'll take that away from 180 and you get 30 degrees. 30 degrees plus 150 equals a total of 180. So this reference angle for part A, I should write part A, is 30 degrees. Let's look at part B. And part B is going to be 960 degrees. I'm going to go ahead and take 960 and start subtracting 360s until I get it within 0 and 360 to help me graph it out. So subtracting a full circle gets us a total of 600 degrees. Subtract 360 again, we get 240 degrees, and now we're finally within our 360. So let's go ahead and draw this out. So remember that we have normal clockwise or counterclockwise direction for this. And 240 degrees happens to be in quadrant 3. Flip to the x-axis. So if 240 goes from here to here, and I want to find this little angle inside, we're going to have to subtract out the top, subtracting out the 180. So 240 minus the 180 gets us a total of, oops, hold on. All right, sorry about that, the lights went out. So this gets a total of 60 degrees. That's our reference angle. So this is 180, and then the extra 60 degrees to get us a total of 240. All right, part C is going to be in radian measure. So part C, we're going to go ahead and draw in our axes. And then what I like to do is I always like to change this to a mixed number. Keep in mind that 2 pi goes a full circle. So 2 pi. All right, so let's change this to a mixed number. 3 goes into 4 one time with 1 left over. So remember that 1 pi is just the top half, and then we're going 1/3 more, and 1/3 is less than the halfway point. So it's going to be over here. Okay? So we went 1, and then we went 1/3 of a pi. So this is the 1/3 of a pi. So it's pi over 3 for your reference angle. And then the last one, I'll do D down here. So we have, again, radian measures. So I'm going to go around, and it's also positive. So pi over 2, pi, 3 pi over 2, and 2 pi. Let's go ahead and change this into a mixed number. 4 goes into 17 4 times with 1 left over. So this is the same thing as saying 4 and 1/3. So we have, oh, not 1/3, I'm sorry, 1/4. Looking at the wrong problem. So it's 4 and 1/4. So we're going to go ahead and go around the circle. And remember that it's going up. That's 1 pi, 2 pi, 3 pi, 4 pi, and then 1 more fourth that goes up here. 1/4 is less than half. All right, so we actually went around 2 full circles and then up a fourth. That 1/4 is pi over 4, and that is the reference angle for D. Okay, we're going to convert from degrees to radians here. So part A, if you want to take 36 degrees and convert it to radian measures, we're going to multiply this by pi over 180 degrees. You want the degrees to cancel for the units. All right, let's go ahead and multiply across the top and across the bottom. You could cross reduce if you want to beforehand, that's fine. And then this reduces to 36 goes into 180 a total of 5 times. So it's pi over 5. And part B is making negative 72 degrees. And we're going to multiply that again by pi over 180 degrees. The degrees, which is the units, should cancel and leave us with radians. So we have negative 72 pi over 180. And that reduces to negative 2 pi over 5. Okay, for this next one, we're now converting from radians to degrees. So the first one, we're going to start with 4 pi over 9, and we're going to multiply it by the pi is going to be on bottom, 180 degrees. You want to keep the degrees on top. So this time, the pi's are going to cancel. And then, actually, I'll just go ahead and cancel so I don't have to multiply such big numbers. 9 goes into 180, a total of 20 times. And so that's going to give you 4 times 20, which is 80 degrees. And for part B, we're going to take the negative 11 pi over 18 and multiply that by 180 degrees over pi. Again, the pi's cancel. 18 goes into 180, a total of 10 times. Use this color. And then multiplying negative 11 times 10 is negative 110 degrees. Oh, shoot. All right, let's go ahead and go on to this next one. So right here, we have, for each measure, find the nearest 2 positive and 2 negative coterminal angles. So coterminal angles are when you add and subtract full circles. So we want to do part A, 165 degrees. So to get another coterminal angle from that, what we're going to do is we're going to go ahead and add a full circle of 360 degrees. So adding 360 degrees to this gets you a total of 525 degrees. And then to get another positive, I'm adding another full circle, which gets you 885 degrees. All right, now that's only positive. We have to find 2 negatives. So again, I'm going to start with 165, but going in the opposite direction means I'm going to subtract. Subtract a full circle of 360 gets you negative 195 degrees. But subtracting another full circle gets you a total of negative 555 degrees. Now part B is in radian measures. So remember 2 pi is a full circle. So we're going to take 6 pi over 5, and to get a full circle, we're going to add 2 pi. But you need a common denominator in order to add this, so I'm going to go ahead and get a common denominator. 6 pi over 5 plus, remember this is over 1, common denominator is 5, so 2 times 5 is 10, so it's 10 pi over 5. 6 plus 10, that's 16 pi over 5, and that's the first positive coterminal angle. Where you need another positive, so I'm going to add another full circle. Since I already found the common denominator, I'm just going to add another 10 pi over 5. So that gets a total of 26 pi over 5. I have 2 positive, and now we're going to do the same thing, but this time we're going to subtract because we want to go backwards to get a negative coterminal angle. So I'm going to subtract 10 pi over 5, which just gets us negative 4 pi over 5 as our first negative. But I'm going to subtract another 10 pi over 5 to get negative 14 pi over 5. Again, you're adding and subtracting full circles. All right, evaluating without a calculator. So what we're going to do is we're going to first draw the measure of the angle and then assign the sine lengths. So this is in radian measures, so we have pi over 2, pi, 3 pi, 3 pi over 2, 2 pi, and 3/4 of a pi, that's going to be right here, between 1/2 and 1 whole. Draw that straight down. And then this is going to have a reference angle of pi over 4. You can just tell by the denominator here. Pi over 4 side lengths are root 2 over 2's. Keep in mind this one on the bottom is negative because it's to the left. Positive up. hypotenuse is always a positive 1. Remember that sine is opposite over your hypotenuse, and opposite of pi over 4, the reference angle closest to the origin, is root 2 over 2. Now it is divided by 1, but I don't need to write divided by 1. We'll just get to the root 2 over 2. All right, let's take a look at part B. Part B is now cosine, and it's still in radian measure. So you have 0, we have pi over 2, pi, 3 pi over 2, and I know pi over 6 is between 0 and a half, so it's going to go over here. This is pi over 6 for my reference angle. And then remember, pi over 6 is the same thing as 30 degrees. Across from that is 1/2. This side is root 3 over 2. Hypotenuse is always 1. None of these are negative because it goes right and up. All right, let's go ahead and evaluate. Now, if you remember what cosine is, cosine happens to be adjacent over hypotenuse. So adjacent to pi over 6 is this square root of 3 over 2. And over 1, because the hypotenuse, but over 1 is the same thing. Right, and then let's go ahead and take a look at C. And C is cosine of pi. So we're going to go ahead and draw out our pi, where it is actually going to land on the axes. So if you're landing on the axes, that means you're not going to draw a triangle. Pi is right here. You're going to use the unit circle. And the coordinate for that point is -1, 0. And if you remember that in a coordinate, cosine is your x, sine is your y. And this particular question wants cosine. And so cosine is -1. All right, let's go ahead and take a look at D. All right, D, we have a negative measure. So that means we're going to go backwards around. So we're going to go, here is negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, this is going to be actually right at the top. It's on the axes. So we're going to use a unit circle again. The coordinate there is 0, 1. Remember that sine is the y value. Cosine is x, sine is y. Since sine is 1, the answer is 1. For E, we're going to look at pi over 3, which is in really quadrant 1. So I'm going to go ahead and just draw that out. Here is pi over 3, and pi over 3 is the same thing as 60 degrees. Across from that is root 3 over 2, and this is 1/2, 1. It's positive because there it's going to the right and up. And then tangent is opposite over adjacent. So tangent of pi over 3, opposite over adjacent. Opposite of this pi over 3 is root 3 over 2 over the adjacent, which is 1/2. You have the option of multiplying top and bottom by the LCD, which is 2, to cancel that out and get square root of 3. Or you can do the copy and then dot and flip this, which gets you the same answer. Okay. All right, let's go ahead and go to F. I'm going to see if I can do that here. So we have cosine of 15 pi over 6. So again, we're going to draw this out, pi over 2, pi, 3 pi over 2, 2 pi. Let's write this as a mixed number. And 6 goes into 15, a total of 2 times, and we have a total of 3 left over, and 3, 6. Oh, look, this actually reduces, right? I could have reduced it from the beginning. So this is a little bit tricky on this one. So we have 2.5 pi. All right, so 2.5. So you're starting here. This is 1 pi. This is 2 pi. And then half of pi leaves you right up here. So it's actually a unit circle again. So we're going to use the coordinate at that point. No triangle. It's 0, 1. And since this is asking for cosine, cosine is your x value, and the x value is 0. All right, let's take a look at these. Next ones are in degrees. So we're going to have to draw it out with degree measures. 90, 180, 270, 360. And then looking at this, you have 225 degrees, which happens to be quadrant 3. Go up to the x-axis. We know that the angle measure from here to here is 225. Remember that we want just the angle inside here, so you have to cover up the top. So 225 minus 180 gets you 45 degrees. That is your reference angle. So the side length for 45 is root 2 over 2, root 2 over 2. Hypotenuse is 1. And since this is asking for cosine of 225 degrees, cosine is adjacent over hypotenuse. Adjacent is this root 2 over 2, hypotenuse is 1. And by the way, this goes to the left, so that's going to be negative. This goes down, that's negative as well. Forgot to put the negatives in. All right, so adjacent side of 45 degrees is right here, which is negative root 2 over 2. Hypotenuse is 1, so dividing by 1 is exactly that. All right, let's look at H. I might not be able to fit that in a picture, so let me go ahead and get another paper. And H starts right here. So we have 150 degrees. So we have 0, 90, 180, 270, and 360. And 150 degrees lands in quadrant 2. Now keeping in mind that 150 degrees is from here to here, 150. So to get this missing angle here, subtract that from 180, and that gets you 30 degrees left. So 30 degrees across from that is 1/2. This side is root 3 over 2, and then that's a root 3. And then these side is negative, this is positive going up. We're trying to find sine, and sine of 150 is going to be opposite over hypotenuse. Opposite of 30 is 1/2. Hypotenuse is 1, so dividing by 1 still leaves you with 1/2. And J, I, you want to do tangent of 315 degrees. So here we go, 0, 90, 180, 270, 360, and 315 degrees is going to be in quadrant 4. And 315 goes around this direction. So to find what's missing, take 360 and subtract 315, and that gets you a total of 45. So this is a 45-degree triangle, and in 45 degrees, you need the side lengths of root 2 over 2, root 2 over 2, and 1. This is negative because it goes down. This is positive to the right. And tangent is opposite over adjacent. So tangent of 315 degrees. Opposite is this negative root 2 over 2 over the adjacent side, which is root 2 over 2. And that gets you, oh, I'm off the page, huh? That gets you negative 1. All right, let's go ahead and go to J. Actually, I could fit that here. So J, we have sine of 270, so we have 0, we have 90, we have 360, oh, not 360, 180, 270, and 360. So 270 is actually on the axis, so we need a unit circle, no triangles. That's 0, negative 1. And it's asking for sine. Remember, sine is the y value. Cosine, sine. So negative 1 is the actual y value. All right, let's look at the last one of these. Into K. Again, this is going to land on the axis because 90 degrees is right up here. So it's a unit circle again, no triangle. The coordinate is 0, 1. Tangent. If you remember tangent, you can either do sine over cosine, or you could do y over x. And I'm just going to use y over x. So my y value here is 1, my x value is 0. And so this is undefined. You can't divide by 0, but define. All right, evaluating without a calculator, more of these type, but it's going to be the special type, secant, cosecant. So we're going to go ahead and start off with our picture. And we know that this is 60 degrees, so between 0 and 90. 60 degrees is up here. That is your reference angle. Across from 60 is root 3 over 2. This side is 1/2. Hypotenuse is 1. Positive, positive. Now, remember, secant is the flip of cosine. Remember, it starts with S, so think of the one that starts with Z. Cosine flipped is hypotenuse over adjacent. So we're going to start with the hypotenuse, which is 1, over the adjacent side, which is 1/2. You can multiply top and bottom by 2, copy dot flip, either one. I did a copy dot flip since the last one I did was the other way. But if you wanted to, you could multiply top and bottom by 2, which would get you 2 as well. All right, let's take a look at part B. Actually, I'm going to see if I can fit this down below here. 210 degrees. So we're looking at 210 being between 180 and 270. So we have here our 210. Keep in mind 210s from here to here. So you have to subtract 210 from 180. That gets you 30 degrees. Across from 30 is 1/2. Negative, it's going down. This side is root 3 over 2, also negative because left. And then what we're evaluating here is cotangent. So if you do cotangent, it's the flip of tangent. And tangent is O over A, so this will be A over O. Adjacent over opposite. So adjacent to 30 degrees is this negative root 3 over 2. And then opposite is negative 1/2. You can multiply top and bottom by the LCD, and that gets you positive root 3. All right, let's take a look at C, and that's cosecant of 225 degrees. So 225 or 0, 90, 180, 270, 360, and if you notice that 225 lands in this quadrant right here. 225 takes you from here to here. So take 225, subtract 180, and that gets you 45 degrees as your reference angle. So I know across from 45s are root 2 over 2. This is negative. Root 2 over 2, again, to the left, negative. That's positive. And then we're looking at cosecant. Cosecant is the flip of sine. So this is going to be H over O. And so hypotenuse is 1 over opposite of 45, which is this negative root 2 over 2. So I'm going to have to rationalize a little bit here. Well, let's go ahead and copy dot flip first. Copy the top, dot flip the bottom. Or you can multiply top and by 2. And then from there you get negative 2 root 2, but you can't leave a radical in the denominator, so multiply by root 2. And that's going to get us negative 2 root 2 over 2. But the 2's can cancel here, so it's just negative root 2. All right, let's go ahead and go on to some radians. So go ahead and go with D here. And we have pi over 6, which is between 0 and pi over 2. So this is going to be over here. Again, pi over 6 is the same thing as 30 degrees. Across from 30 is 1/2. Across here is root 3 over 2. Hypotenuse is 1. Positive, positive. And cotangent is the flip of tangent. So I'll put pi over 6. So the flip of tangent is going to be A over O, adjacent over opposite. Adjacent to this pi over 6 is root 3 over 2 over the opposite, which is 1/2. Let's multiply top and bottom by 2, and you get root 3. All right, let's go ahead and go to E. E is 3 pi over 4. So this is where pi over 2 is. This is pi. 3 pi over 4 is right here. And this side, this is pi over 4. Pi over 4, and then we have across from pi over 4 is going to be root 2 over 2. Root 2 over 2. Same thing as a 45-degree angle. This goes to the left, and this goes up. That's positive. And then we're going to evaluate here the secant. And secant is the reciprocal of cosine. So this is going to be hypotenuse over adjacent. So hypotenuse here is 1 over the adjacent side, which is this negative root 2 over 2. Again, we can, since the last one I did copy dot flip, I'll multiply this by 2 this time. So we can see both. So this is 2 over negative root 2. Have to rationalize by multiplying top and bottom by root 2. Again, the 2 root 2 over 2. Keep in mind it's negative, but the 2's cancel, so this will be negative root 2. All right, F is cosecant of 8 pi over 3. So I'm going to go ahead and put in my angle measures here. Okay, let's write that as a mixed number so we know where it lands. So 3 goes into 8 a total of 2 times with 2 left over. So 2 pi, that's 1 pi, 2 pi for a full circle, and 2/3 ends up being over here. So this is pi over 3, you could tell by the denominator. Pi over 3, same thing as 60 degrees. Across from that is root 3 over 2, 1/2, both, or this one's negative, it's on the bottom, positive up. And we want to evaluate cosecant. Cosecant is the flip of sine. So flipping sine is going to be hypotenuse over opposite. The hypotenuse is 1. Opposite of pi over 3 is root 3 over 2. And we'll multiply top and bottom by 2. Cancels the bottom. So you have 2 over root 3, but you can't have a radical on the bottom. So multiply top and bottom by root 3, and that gets you 2 root 3 over 3. All right, and then we're going to go ahead and do the last set of these trig ones. So here we go. G, we're looking at negative 270 degrees, so we're going backwards. Negative 90, negative 180, negative 270, and back to 360. Notice 270 is on the axis, so we just need the unit circle, no triangle. 0, 1. Secant is the flip of cosine. And cosine, remember, is the x value. Remember, it's cosine, sine. So cosine theta, sine theta. Cosine is 0. So if I plug in 0, that's undefined. All right, H, we're looking at cotangent of 3 pi over 2. Again, that's going to be landing on the axis of pi over 2. Because 3 pi over 2 is here at the bottom. So since it's at the bottom, we're using a unit circle. This coordinate down here is 0, negative 1. And we want to find out what is the cotangent. And cotangent is the flip of tangent. Now, if you remember what tangent was y over x. So technically, this is going to be x over y. So if you look at what x value is, x is 0, y is negative 1. That gets us 0. And let's go here. Secant of 3 pi. So secant is 3 pi. So this is going to be 0. Here's pi. This is 2 pi. And I'll go ahead and put these in, but we don't need to have any halves. This is the whole full 3 pi. So this is 1 pi, 2 pi, 3 pi lands us right here. It's on the axes. Let's go ahead and use this coordinate, which is negative 1, 0. Keep in mind that secant is the flip of cosine. So cosine is the x value of negative 1. 1 over negative 1 is negative 1. All right, and then the last part is evaluating with a calculator. So I guess I could sneak that in here right here. And so you're just going to make sure you're in the right mode. So this one right here is making sure that you're in degree mode. So you have to put in cotangent as 1 divided by tangent of 35 degrees. So 1 divided by tangent of 35 gets you approximately 1.428. It wants 3 decimal places here. And the next one for part B, cosecant is the flip of sine. So sine of 14 pi over 15. And we're going to put that in radian mode. So make sure you change the mode in the calculator to radians. And now we're going to put 1 divided by sine of 14 pi divided by 15. And that gets us a total of 4.8. And then rounding off to 3, that'll make that an 810. And that is it. Okay. Hopefully you had a chance to figure this out.